back. Today we join a solitary builder as he turns raw timber into a permanent sanctuary, racing against the turn of the seasons. The first step in any structural frame is extraction. Heavy metal chains ensure the log won't slip during the haul. Pulling massive weight across uneven forest floors requires a low center of gravity and absolute traction. Bark holds moisture and invites decay, making immediate peeling essential for structural timber. A sharp draw knife strips away the cambium layer. Sanding follows, sealing the wood grain against the coming weather and creating a uniform surface for precise joinery. Moving heavy timber by hand relies entirely on leverage and momentum. Dragging from the leading end minimizes ground friction. Early staging establishes the working footprint. Wooden wedges are driven deep to lock the temporary framing in place. Unlike metal fasteners, timber pegs expand and contract with the surrounding wood, creating a joint that actually tightens under environmental stress. This traditional approach absorbs shock far better than rigid steel. As the sun drops, temperature shifts affect the wood's surface tension. Calipers provide the exact diameter needed to calculate load-bearing capacity. Every dimension is logged by hand. In custom timber framing, understanding the unique taper of each log dictates exactly where it will sit in the final wall assembly. Working under artificial light narrows focus to the immediate surface. Once smoothed, each log receives a specific sequence number. This index system transforms a scattered pile of raw material into a precise kit of parts, ensuring the assembly phase will proceed without hesitation. Equipment maintenance is the quiet backbone of the build. High-heat welding fuses the rusted tubular steel, restoring the structural integrity of the towing hitch for the heavy lifting ahead. Midwinter, the earth hardens into a solid mass. A pickaxe breaks the frost line, while manual shoveling clears the debris. Excavating frozen soil is punishing, but it prevents the trench walls from collapsing. Wooden boards shield the freshly opened excavation from overnight snow accumulation. Protecting the subsoil moisture balance is critical before pouring the foundation. requires a precise water ratio to cure properly in cold conditions. The mixture must flow easily, but retain enough density to bridge the uneven ground. Jagged rocks are embedded directly into the wet pour. This acts as coarse aggregate, drastically increasing the compressive strength of the footing while reducing the total volume of concrete needed. Wooden forms are then lowered to shape the visible plinth. A threaded metal rod is set exactly plumb in the center. This anchor will eventually bolt the timber sill plate directly to the earth. Once the chemical curing process hardens the concrete, the wooden forms are pried away. The resulting blocks are solid, but heavy stone is brought in to provide secondary reinforcement around the exposed bases. A smooth surface finish prevents water from pooling against the concrete, mitigating future freeze-thaw damage. Heavy stones are pressed into the soft concrete around the structural posts. This traditional technique creates a wider load-spreading footprint and deflects ground moisture away from the vulnerable timber end grain. Careful troweling seals the union between rock and cement, ensuring no air pockets remain to harbor dampness. structural integrity of a cabin relies entirely on its joinery. A chainsaw rapidly clears the bulk material, carving a deep saddle. Hand cleaning removes the frayed fibers, leaving a hard, smooth surface that will compress tightly under the weight of the roof. Heavy metal bolts are driven down to lock the courses together. With the corners secured, the next section of wall is dragged into range. Moving timber with a low-slung strap keeps the center of gravity near the earth, maximizing the pulling power. Precise chainsaw work requires reading the grain. The blade slices cleanly through the fibers, establishing the critical angle for the overlapping corners. The new log settles firmly into the carved saddle. Long drill bits are necessary to bridge the thickest points of the intersection. Tightening the bolt mechanically forces the two uneven wood surfaces to compress into a single unified structural element. As the walls rise, brute force gives way to mechanical advantage. A massive tripod is erected over the site. This simple geometry provides an incredibly stable lifting point, capable of handling immense downward forces. Drilling through the apex allows a heavy-duty steel eye bolt to be threaded directly into the heartwood, sinking the hardware flush. The hardware flush against the timber ensures the lifting load will be transferred into the wood itself, rather than shearing the metal shaft. A heavy steel cable binds the apex together. Tension locks the three independent legs into one rigid, load-bearing pyramid. Mechanized assistance dramatically speeds the heavy transport. The tractor drags raw mass into the hoist, where the builder immediately steps in to shape it. Rough cutting on the ground is safer and far more efficient than working at elevation. Every timber is pulled close and carefully measured. Trimming the ends now establishes the final exterior dimensions of the cabin. A clean crosscut seals the end grain better than a rough break, slowing the rate at which moisture escapes and preventing deep structural checking. The base will magnify into a serious lean at the roofline. Spirit levels verify the horizontal plane across the concrete blocks. Working high off the ground introduces new risks. A temporary weld secures the upper frame against wind shear. Down below, the complex joinery continues. The deep, oval-shaped saddle notch is the hallmark of traditional log building. The curved profile distributes weight smoothly across the underlying log, eliminating the concentrated pressure points that cause timber to split. Refining the edges guarantees a weather-tight seal that will lock out the harsh winter hydraulic power gently sets the heavy timber onto the anchor rods. Once the horizontal base is locked, smaller vertical posts are seated to provide intermediate support along the spanning sections. crane allows the builder to float the timber right at the working edge. Standing on the piece provides vital body weight to counter the kickback of the saw. A sharp V-notch creates a self-centering joint that will actively squeeze tighter as the wood inevitably shrinks. Knots disrupt the predictable straight grain. A metal scribe traces the exact irregularity of the lower log onto the upper one. Hand chiseling allows for micro-adjustments that heavy machinery simply cannot achieve. Sitting directly over the joint provides the perfect viewing angle. Removing small chips releases the internal tension in the wood without compromising its load-bearing strength. Nylon straps protect the smooth wood surface from gouging during the heavy lift. Ratchet straps lock the remaining material for transport. Back on the wall, protruding ends are flushed up to maintain a clean architectural line. scribing and carving occur in a continuous cycle. The chainsaw aggressively hogs out the waste material from the curved recess. An angle grinder, equipped with a sanding disc, then buffs away the saw marks. This frictionless surface allows the upper log to slide seamlessly down into its final position. Marking the exact contour is crucial for a tight envelope. Small wooden edges hold the gap open just enough to allow final sanding without pinching the grinder disc. Mechanical hoists multiply human pulling power, inching the massive timber exactly over its destination. Gravity alone is rarely enough to seat a friction-fit joint. A massive wooden mallet delivers tremendous kinetic energy without scarring the timber. Driving the corner down forces the fibers to compress, creating an interlocking seal that resists both wind and water. Ground-level preparation keeps the high-altitude assembly moving safely. Compressed air blows away the fine sawdust that could otherwise prevent a flush connection. With the piece clean, the tractor hauls it to the base of the wall. Once the crane sets it down, the focus shifts to geometry. A taut string line acts as an absolute visual reference, checking for lateral volume across the long spans. In timber framing, true plumb and level must be actively maintained, as raw logs naturally twist as they dry. At this height, every movement requires balance and intent. The crane bears the physical weight, allowing the builder to focus entirely on guiding the joint. Working directly on the narrow top plate demands intense physical endurance as the structure finally nears its peak.
until you have to. No, push, push. Oh. Leave it. Okay. Yeah. Still those 15 centimeters.
The upper courses tie the separate walls into a unified, rigid box. This final perimeter locks the entire lower structure together.
Okay. Now we go.
Trimming the top plate creates a level bearing surface for the roof frame. The horizontal beams are massive, spanning the open void to carry the immense future weight of winter snowfall.
Faster, faster.
Heavy steel brackets anchor the primary beams against high winds. This mechanical fastening ensures the roof structure cannot lift or shift away from the wall. Carrying these upward timbers pushes human limits. Balancing the heavy logs while climbing requires coordinated strength and deep trust. Every beam placed across the span physically ties the opposing sides of the cabin together.
Yes.
Long metal pins are driven deep through the intersection. These invisible steel shafts provide immense shear strength at the most vulnerable joints. final trim cleans the ridgeline. With the structural canopy established, modern utility is integrated. Stapling electrocoil conite directly against the high beams keeps it protected and out of sight, threading power through the heavy timber before the final roofing material goes on. The completed frame stands as a testament to precision and endurance. From the interior, the interlocking timber creates a quiet, incredibly strong geometric canopy. Every tight notch and flush saddle joint represents hours of unseen labor. The heavy wood acts as a massive thermal battery, ready to absorb and radiate heat. What began as scattered pines is now an integrated, permanent shelter. In the end, structure, landscape, and daily routine operate as one system. A place that produces, protects, and sustains itself.